Welcome everyone. In this video I will try to make some use of one of my Peltier cooler. So if you've been watching my videos lately, you could see this guy because I tried to test something with this setup. So what is here is a CPU cooler on this side, so you can see the heat pipes here, 6 heat pipes in this cooler, and there is a 12 centimeter fan. It's similar to this. And then on the other side here, there is an aluminum heatsink. In between the two sides, we have a TEC12708 Peltier cooler, so it's an 8 ampere unit. And you can see that there is a small foam just to separate the cold side, which is this side here, from the hot side, which is this side here. So this CPU cooler will make sure that we cool the hot side of the Peltier cooler sufficiently, and I chose the 8 ampere unit because I can make sure that I can cool it more or less to 30-35 degrees while running almost the maximum current through the 8 ampere unit. And if I was moving towards the 10 or 15 ampere units, then I would have a huge issue with the overheating, because these kind of coolers are just simply not capable of providing enough cooling power, because as you can see that there is a limited surface area available, and that's not so good for us. So once again, hot side cooling is this, cold side is this. You can see that I made some dents and some holes here and there because I will try to run a screw through these holes. Actually, I cut threads in these holes, so I will tell you later what is the purpose of this thing and what is the purpose of the video. So this will be another 8 centimeter fan. I will use this on the cold side, so on this side here, and this will run not at 12 volts as it should, but maybe at 4 to 6 volts. So I won't use it on its maximum performance because I just gently want to mix the air with this fan, or circulate the air. So I printed 2 of these things. It's basically just some kind of mounting mechanism or mounting plates. I will show you soon what is this, but we will have this. In the corner here we have a huge amount of washers, screws, and nuts. This will be also used in this project. And then, as you can see, we have a 12 volt 30 amp power supply. This particular project does not require this powerful power supply. It would be enough to have a 12 volt 10 amp power supply, just to make sure that you can provide the maximum power to the Peltier cooler safely. But this was the power supply which is available for me, so for demonstration purposes I will use this. But I want to repeat again that this is a huge overkill for this kind of power supply. And also I might run 12 volts through the Peltier cooler which I'm using, but I will not run 8 amps through it, because you know that after a certain point the Peltier effect will be overpowered by the Joule heating. So therefore further increasing the current running through your Peltier cooler will decrease the performance of it, because you start to heat it, and that's not good. So this is also introduced now. So we'll need a power supply, and finally we have these, I don't know what's the best word for these kind of things, but it's, I think I would say, corrugated plastic. So I don't know if you can look into this. I try to cover it, but this specific thing has channels. And this is good for us for 2 things. One thing is that in this direction, so parallel with the channels, it's very easy to cut. So you can cut this thing to size relatively easily. Another thing is that in these channels, the air is being trapped. So this is a good thermal insulator to a certain extent, of course. And it's lightweight, but still rigid structurally, actually in both directions. It's quite good. And you can see that there is a hole already here, so I can put my hand through it. And there are, additionally to this, 5 another sheets. And what has 6 sides or faces? A box. So now I can reveal what I try to do is I try to build a cooling box. Because a lot of people were asking about making Peltier coolers into cooling box, and there was one particular viewer which was complaining that I was making too many Peltier related videos, but I was not showing anything useful. However, I think that those information that I published is very useful, because all or most of the YouTube videos are quite misleading when it comes to Peltier cooling, and I always try to show everything accurately, scientifically, and in a systematic way. But that's not this video's topic. So there's a hole here, and each sheet is 40 by 40 centimeters exactly. I will show you how to build this. But yeah, so if I put together this 6 sheets, then I will have a 64-liter volume inside this box. And this 64-liter volume will be cooled down with this single Peltier cooler. I expect something around 40-50 watts of cooling power from this particular unit. We will see. But why I have this hole is basically just to have the cold side inside the box. So I made the main hole for the heatsink, and I cut some holes. So I will try to assemble it and show it to you. So now the cooler is placed here, as you can see. So the cooler goes through this panel, and then why I printed this and why I cut the hole here is because of this. So now I will have these adapters or mounts and place this over the holes on the 2 sides. So one screw will go, I just try to show it. So one screw will go through the plastic part and will end up in the thread in the heatsink, and 2 other screws with some washers and nuts will go through this plastic panel. So basically this plastic panel, we will see how strongly, but it will support the wall cooler. If it is needed, I will add some extra support, but I haven't tested it, so I don't know. So this thing, I try to rotate it. So this will be entirely inside the box, as you can see it now, and this part of course will be surrounded by some sort of foam here, and that foam will make sure that not too much heat is going into the cold side or towards the cold side. So what I will use here is, for example, this duct tape. This will be used just to fix the 6 sides or 5 sides together, because the sixth side will be the top of this unit, which we will be able to open and close. So this will be more like a chest and not like a regular refrigerator where you have a door and you open it like a regular door, but this will be more like a chest. And I have my reasons for that, but I will explain it later. And then we will use some sort of silicone. This is used in bathrooms. So in bathrooms you just use this to just fix the tiles or the gap in between the tiles. And for us this just adds a little bit of structural rigidity, but the main reason is that I want to make this thing airtight. So then to make it airtight I will also use a foam based sealing. So this is just a regular tape. So one side is adhesive and the other side is just regular foam. So this is used in windows as the illustration shows. So this foam will be used for the door, so that will hopefully seal the door properly. And this video will be two parts. The first part, I will just put these things together and just make a test run with the assembled box, and we will see how the temperatures develop. And the second part, I will actually buy some insulator, so polystyrene foam or something like that, hopefully some foam like this. I will try to look for something, so that thing will be used around this kind of plastic, and then I will add another layer of this plastic, so the interior will be the same as the exterior, so will be made of this kind of corrugated plastic sheet, but in between these two sheets there will be a layer of foam like this. And why is that good? More structural stability, and then, as I said, this can act as a sort of an insulator, because you have a plastic which is already a bad insulator, but then you have an air pocket, and then you have another layer of plastic on the other side, and then you put the plastic foam there, and then you put another layer of plastic sheet like this, which will be the exterior of the wall thing. Therefore, hopefully we will not need too much cooling power, we will need time, but I will share some tips and tricks with you, and that will hopefully help you to build a better cooling box, maybe even better than mine. So this will be long, and maybe I will go into too much details, but what I want is to go beyond the already available videos, because there are like hundreds of videos of everyone building Peltier based cooling boxes, but most of them, there are some very refreshing exceptions, but most of them do not explain anything. They are just using some hot glue guns and put everything together with some crappy music running behind the video, and then they try to just show you that they can cool something. But here we will use a bit more scientific and engineering approach, so I will break down all the small things and try to explain you everything, and hopefully I will help you to build even a better thing than I'm building now, because this is my first experiment ever building this kind of cooling boxes, so I might fail, but we can learn during this journey. So now I will assemble a box out of these sheets, and then I will show you the box and show you the final result of this kind of mess here. So as you can see, the 3 walls are assembled and the 4th wall is just right there. So I want to show you another tip again. So as you can see, the tape is outside the box, because the inner edges will be filled with this silicone glue that I was showing to you. But let's go here. I put tape here and also here on the other side, but what is interesting here is this small gap. So there is 4 mm difference between this wall and this wall, and that there is a reason for that. So as you can see, this sheet here is on the bottom plate, so this is 4 mm above the ground here. But this thing here is actually touching the ground, so that's why you could see the difference on the top of the box, because there is here you can see that the bottom of this sheet is 4 mm above the bottom of this sheet at the other corner. And why I did this is because when I put the lid on this thing, then this will guide the lid nicely, or the top. So I want to use that. So now I continue putting together this box again. So I assembled the box, as you can see. It's nice and rigid, and I was just using these duct tapes, so I just added them to the corner. Here it's like tripled, so there are like the neighbor sheets, and also the bottom is connected to each other, so this adds some additional rigidity. And then here you can see the thing that I printed. So this T-shaped plate holds the heatsink and the plastic sheet together. And then here we have our cooler. This area is roughly 4 centimeters or 5 centimeters. So this is a bit critical. I have to cut and carve or maybe chisel some foam there, but it's okay. And then if you go inside the box, and you can see that this will be our cold side, and this will provide the cooling for the rest of the volume here. So you can see the box here. It's really nice. You can see some tools in the corner. So that's what I was using. So this here is 64 liters. And then the 6th sheet will come on top of this, and that will be the complete box. So what I will do now is I clean up a little bit, and then we will start the testing soon. So I changed my mind and I decided to finish the whole box and add the insulation and everything. So I will do a little tour or something like that to show you all the parts and discuss a few things about the box, and then I will do some measurements. So as I started to tell, this box is using a Peltier cooler, TEC12708, and the Peltier cooler is powered by this power supply. This is a 12 volt 30 amp power supply. 30 amps is too much. I mean, we just don't need this powerful power supply for one single Peltier cooler. And it's good that it is 12 volts, because usually when you run the maximum current through the Peltier cooler, then they run around 15 to 18 volts, depending on other circumstances. But that means when you have 15 to 18 volts, then the Peltier cooler is running on the maximum current. Therefore, if you limit the voltage to 12 volts, it will run on a lower current. And I don't remember which was the current, but if I'm right, it should be around 6 amps. And that is actually the sweet spot of this device. So we will see if this really works. And then on the top of this unit, we have some thermometers and stuff. Those are other thermometers which I built previously. It doesn't belong to this device, but I will use it in this experiment. And now I will just grab the camera and show you around this device. So these are just the thermometers that I will be using during the experiment, so it's not really necessary to have them now. So first of all, this corrugated plastic sheet adds some small extra heat insulation or thermal insulation, but what is more important, it adds more additional structural stability. You can see that I added this handle, so it's just a regular door handle. So we will open this thing as a chest. So let me open this. So this goes up, and you can see that around the perimeter of this box I added some foam, so they hinder the circulation of the air and so on. I haven't made any way for the cables, so I will just run it outside somewhere at the corner, for example. But you can see that we have the Peltier unit, and finally I decided to use a small 4 centimeter fan, and this is like a very small performance fan. I think it runs at 20 milliamps at 12 volts, so it just barely moves the air, but that's what I want. And because since it's a 12 volt device, then I can run it with this power supply there. So I can directly connect it. So I will just put the cable somewhere and remove it. So as you can see, this is also a plastic. I added some hot glue here and there just to fix it to it. But you can see that, for example, we have these hinges here. So that is fixed by a normal nut and stuff. And we have another box inside. So this was the main box, and then I built the insulation foam around the box. and finally I added this external layer. And in the outside, or in this shell, or these faces, I just have this tape, and I have more or less precisely cut sheets. What this means is that this tape is enough to hold everything together, but in the bottom, now I can't really show it right now, I just cannot flip this thing, but from the bottom I have several screws running through the bottom sheet and then the side sheets. So that adds some extra stability. And then we have the Peltier cooler. So let's talk about the Peltier cooler a little bit. So as you can see, I added foam around this thing. So hopefully I insulated most of the things properly. What I mean is that on the other side of this blue foam, we have another layer of this plastic sheet. And then on the other side of that plastic sheet, we have the aluminum heatsink that you saw with the 4 centimeter fan. So as you can see, this is a two-sided 6 heat pipe heatsink. It's a regular CPU cooler, and then it's a 10 by 10 area, let's say, or contour. And then I made a cable with these V-shaped connectors for the fan, this guy. And then I have these very nice spring terminals and quite thick cables, 2.5 millimeters, so I can run high current through this. And this is for the Peltier cooler. So this is all basically. I added some insulation here as well, just to hinder any kind of draft. And you can see that inside we have the blue foam, so this is more or less airtight connection. Why I made this into a chest instead of having something like a refrigerator is because when I open the chest, then I don't create too much draft, first of all, and also the air, which is cold, is accumulating in the bottom of that box. So just the basic physics, if you open the fridge door, then the air can sort of flow out, and then you only depend on the objects that you are storing and cooling inside the box. But if it's empty, then you want to keep, or even if it's filled, you want to have the air cool, because that's also a layer of insulation, if we can think about that in that way. So this is the box. So what I will do is I just fix the camera again and give you some more details. So we have this 4-channel digital thermometer, which is capable of saving the data on a micro USB card. So what I will do here is I start this unit, I measure the current, and then I measure the temperature inside the box. And first I will run this box empty. I'm just curious about the development of the air temperature, and then I will add some objects, maybe in a next video or in a second video, because this is getting long now, and we will see. And I will not record the whole thing because it's just waste of your time to watch. So what I will do, I will just record this thing until I start. And then, since I record the data here, I will show some charts when I discuss the things. And the time is also saved on the SD card, so you will see how the temperature develops inside the box by the time. And what I will do, I will put some thermometers inside the chamber, let's say on this corner inside and in the middle. I will put one thermometer on the heatsink, and I will just keep one outside just to log the room temperature. So for example, if the hot air coming out from the CPU cooler, which cools the hot side of the Peltier cooler, warms up the room, then we will notice the change. So let me assemble the system and we will start the experiment. So I assembled the system, The cables are a bit short for this test, so I had to put the thermometer here, so I cannot really show the screen, but since the data will be recorded, nothing is being lost. I also added this here, the K-type thermocouple thermometer, which shows the room temperature now, 26.3, 26.4 degrees Celsius. And at the end of the experiment, or during the experiment, this will measure the temperature of the CPU cooler. It will not log the temperature, but we will see what happens. So I can check it manually. So this is the room temperature. So this should measure the temperature outside the box, and then the rest of the thermometers, the 3 other thermometers, are inside the box. One will measure the heatsink temperature. I tried to attach to it properly, but due to the size of the heatsink, I could not really squeeze this digital thermometer in between the fins. But it is touching it, but maybe not in the best way. And then there are 2 other thermometers. One is in the other corner on this side, and one is just simply at the bottom in the very middle of the box. And you can see that's the power supply, everything is wired up. So I will get a current meter, and I will measure the current on this loop once I turn on this extension. So we have our power meter or multimeter. So I start up this device and see if I messed up anything with the connections. So it is running, as you can hear. And I turn on the logging immediately. So now we are logging on the card. You can hear that the power supply is relatively loud, and it is because we have the load on it. So let me check the voltage. $12.17, and let me check the current. Uh, 4.9, let's say 5 amps. That's quite good. Let's leave it like this, and then now I'm just running the test, and we will see what happens. So I just want to give you a small update. The test has been running for 35 minutes. First of all, I added another fan on the top of this CPU cooler, because this fan was not sufficient for cooling the heatsink, and the temperature now is 4 degrees lower. So instead of 38 degrees, now it's 34 degrees on the CPU cooler, because I added that additional fan. But I think I will add 2 fans with better performance to cool this even lower, because I believe that now, since we are running roughly 62-63 watts through the Peltier cooler, and we are removing roughly 30-40 watts, so total there is around 100 watts. The CPU cooler should be able to get rid of that, but seems like the fans are not good enough. So once again I added that fan. I haven't changed anything else, and now the heatsink inside is at 5.5 degrees. One of the thermometers is at exactly 18 degrees, and the other is at 14.5. But notice it again, this is a very small performance cooler. It's empty, and it has been running only for roughly 35 minutes. So we should give it some more time, and we should see what happens. So now the experiment has been running for roughly 80 minutes, so more than 1 hour. The temperature on the hot side is still 34 degrees. And then if I check the thermometer up here, the heatsink is at 4.3 degrees, and then one of the thermometer is showing 16 degrees, and the other is showing 12.8 degrees, and the room temperature is still 25.5 degrees. So now the cooling slowed down a little bit, but we are still going. So I keep this thing running, and we will see how the temperature develops in another roughly half an hour, 40 minutes. So this will be my last check-in in this video. The equipment has been running for 2 hours. The hot side temperature on the CPU cooler is still 34 degrees Celsius, and then the temperatures inside the box are the following. So on the heatsink, the thermometer shows 4.3 and sometimes 4 degrees Celsius, and then one of the thermometers show 15.8 and the other thermometer shows 12.8 degrees Celsius, and the room temperature is still 25.5 degrees Celsius. So it seems like that this will be the limit of this kind of equipment. So now we can guess some things which can go wrong here. So maybe some warm air is leaking into the box. That can be one problem. The other problem is that the hot side is not cooled properly. I will fix that, and I will replace the fan in it with a better and stronger one and see if it improves our measurements. And then also it is just the case that the Peltier cooler is not cooling well, because it's a low performance unit. I think the cooling power of this is around 80 degrees, but in that case the temperature difference is quite low, nearly zero. So this is it. So now what I'm going to do is we will just look at the different curves for a few minutes and discuss the further possibilities with this kind of setup. So let's go to the computer and check the numbers. So let's talk about the curve a little bit. So we have the 4 curves for the 4 different thermometers. So let's start from the top. So this was the room temperature measurement, and you can see this that it stayed pretty much the same during the whole time. So this was going on for 2 hours. So you can see that the measurement stops at 7,200 seconds, which is 2 hours. And then the red curve is the corner of the box. So that was like the farthest away from the heatsink, which is the cold side heatsink. And then the other guy was a bit closer. That was in the middle of the box, at the bottom of the box. So you could see that there is like a 4 degrees difference or 3 degrees difference between the two temperatures. And then this black curve is directly measuring the temperature of the heatsink. So I tried to attach a thermometer to the heatsink, and I tried to see how the temperature is evolving there. So as you can see that this is pretty much sort of an exponential decay, as it should be. And then the curve flattens out at around 4 or 5 degrees, and that is suggesting that this is pretty much the end of this kind of system. So now, as I said previously, I will look into the possible ways to upgrade or improve this first without touching the setup. So I don't want to replace or add more Peltiers or something like that, so that I want to keep this as compact as possible. And we will see if we can reach better temperatures, because I think the empty box itself should reach this 4 degrees region. Regular refrigerators run around 4 degrees, or they are suggested to be run at around 4 degrees Celsius. That's like the safe temperature to inhibit or restrict the growth of bacteria on your food and so on. So we try to go to this region with these top 2 curves with the next experiment. And as I said, I will look for leakage. Then I will try to replace the fans on the hot side cooler, because I believe that the hot side should be much more colder. I will look for other ways of improving the cooling. Maybe I will also replace the small fan inside the box, because maybe this is not running the air sufficiently. As I said, this is a very weak 12 volt fan, and I will figure out something. Also, I could put some insulation inside the box to decrease the volume of air which needs to be cooled. So we will see. But as you could see so far, we could reach these kind of temperatures inside the box with just one single Peltier cooler running at 5 amps, and that's all. So in the next video I will try to make some improvements and just rerun this test, because the system is done, the box is done, and we just need to find some ways to improve it. So I hope you liked this video. Don't forget to visit my website, which is curiousscientist.tech, and don't forget to subscribe. I will upload a lot of similar videos, and I will try to figure out better cooling methods or better methods where we can use Peltiers in a smart way. And see you in the next video.